for our first question, how is the how do you feel about nuclear warfare?
I think it's terrible.
Um,
I hope we never see any more exploded.
what
Are there different sizes to the nuclear bombs?
Oh yes, yes.
Is there like a scale of them? Like, is there like a have to be scale to make these certain bombs?
Okay, they measure. There are two types of bombs. There's the atomic bomb, or so-called fission bomb, which was exploded during World War II at Nagasaki and Hiroshima, and those are their energy is measured in kilotons of TNT. So how many thousands of tons of TNT, which is a standard explosive, would be needed to produce the same effect? And I believe the Hiroshima bomb was 30 kilotons. I've forgotten how many thousands of people were killed immediately. You can look that up on Wikipedia. It's an awful, horrible thing. Since then, in the 50s, they developed a different type of bomb called a fusion bomb, the so-called hydrogen bomb. And it can produce explosions that are measured in hundreds and thousands of kilotons. None has been exploded in warfare. Not, in fact, the only two bombs that have been exploded in warfare were the Hiroshima and Nagasaki bombs during World War II. The United States felt that it had no option other than to do that. They were, I don't know how much you know about World War II, but it got to the point where the only thing they had left to do was to invade Japan.
Yeah, and they would like cost about 1 million troops that would be dead. So they were
that was the belief, and
yeah.
so that would. I had a friend, one of my colleagues here, who participated in producing the bomb at Los Alamos, and he said they had no doubt that that was something that had to be done. Now bombs are produced in a whole range of sizes. The U.S., both the U.S. and the former USSR have produced hydrogen bombs and tested some of them. I guess the most famous explosion was the Bikini Atoll. That's a island somewhere in the South Pacific.
Yeah.
And you can find information on that. And that was, I think that may have been the first hydrogen bomb test. And those, like I say, those are much worse than, much more powerful than atomic bombs. But like I said, the U.S. arsenal has a set of models of bombs, of ranges of energies. There used to be a time when they talked about tactical nuclear weapons, that is, weapons that would be used on the battlefield by infantry units to fire at other infantry units, and unfortunately I think that has gotten out.
Yeah, that's good.
Would you mind me moving this closer to you? That way I could pick you up a little bit better.
Oh, you're recording?
Yeah.
All right. Yeah. Thanks for telling me.
Sorry.
I'm just looking at this. So the Hiroshima and Nagasaki bombs, there were two different types of bombs?
Yes, one was a plutonium bomb and one was a uranium bomb.
So, do you know how that reaction occurs? Because when I was looking it up, I couldn't find specifically what it says. It had something to do with they split the atoms of the bomb, and that would cause the reaction. Is that correct?
Okay, both of them. I guess I'd have to look up. I haven't thought about the differences between them, but both of those work off of a process called fission. When you get a nucleus that's very large, that has a lot of neutrons and protons in it, sometimes the nucleus can decay. That is, it has enough floating around energy in it that it can spontaneously split into two or more parts. And some of those parts are neutrons. You know, neutron is, what do you know about neutrons?
Neutrons are they're in the nucleus with the protons, and they have no charge.
Mm-hmm.
And they don't have like an exact spot in the nucleus. They kind of just like float around inside the nucleus. Though.
Right. Okay.
They won't go outside of the nucleus either.
So when fission occurs, some neutrons are produced, and those neutrons can go and hit another nucleus and provide enough energy to make that nucleus go through fission. And then that produces neutrons, and those neutrons can cause other nuclei to go through fission, okay? That happens in a nuclear reactor. Sharon Harris does that all. We've got a nuclear reactor across the street. They use that fission process to heat up water, which drives a turbine that produces the electricity that runs the lights. Okay, those reactions are done in a very careful way with a geometry and some devices that slow down the neutrons that are produced, so that the reaction never gets at a very high level, and the uranium fuel heats up water, but it doesn't produce a whole lot of energy at one time. In a bomb, it's set up in a different way so that all the nuclei go through fission very rapidly, and it produces this giant explosion. Okay.
Could heat or cold affect the bomb, on how it reacts and stuff?
Not significantly.
This is a little off topic, but do you think the U.S. should fear North Korea and their nuclear weapons?
Yeah. Mm-hmm.
Or do you think they're more advanced than we are in
no.
terms of the bombs? So you think is there a new way to counterattack that? If they were to shoot one off, is there any way for us to
stop it before?
Yeah.
No way.
No.
How long does it take to make a nuclear bomb?
Well, it took the U.S. in World War II about a year and a half, 2 years, I guess, to do it. The process of fission was first demonstrated by Enrico Fermi and his group at the University of Chicago about 1941-42, and it was quickly realized, well, in fact, it was realized before, that fission was achieved in a reactor. It was realized that you could make a bomb with it, and the atomic bomb was first tested in 44?
Yeah, I think in New Mexico, right?
Right, at Alamogordo. Yeah. So it was very rapid. The fear today is of some rogue country like North Korea producing a bomb and firing off, and even a little small one would cause terrible damage. And it would lead to an enormous war. I mean, these are not simple, easy to solve problems. No more than the Middle East is an easy to solve problem.
Yeah, so it's just we have to just know when. Do we have any information on their stuff at all? You know?
Oh yes.
Yeah.
Okay.
I
don't know it, but the information that spy satellites and spies and monitoring of the internet bring is amazing.
Do you know how many people it would actually kind of take to make the bomb without making something go wrong or?
Let's see. I don't know how many people worked at Los Alamos, but it can't have been more than a couple of thousand, including all the military and the security people. That's still a laboratory. Our group works out there once in a while, not on defense-related issues, but on science issues. And it's a town of 14,000 people.
So was the U.S. the first to start thinking nuclear warfare, or was it the Nazis? Because what I've read is that some of the Nazi scientists and stuff, when Hitler took over, they all came over here to help us. So I was just
No, what the history is that Hahn and Meitner discovered nuclear fission in the late 30s, and as soon as that was measured, the fact they discovered that if you took a heavy enough nucleus, it would spontaneously break into two parts and produce neutrons. And people quickly realized that this could be used to make power or could be used to make bombs. The previous to that time, there had already been a migration of scientists from Germany because Germany was persecuting the Jews. And so a lot of scientists, such as Einstein, left Germany and Switzerland and Austria. Yes?
I got called into Canberra, but those people, they were equally frustrated about Canberra's proprietary storing data.
Okay.
I think I might find a way out how to get an Excel file out, but...
So that stuff you paid for did not produce that type of file?
No, actually what I paid for, it doesn't have anything to do with what we need to do. So that was sort of a bill of goods. But I'm hoping to get some information how to get stuff out to Excel, but the Surrey guys gave up on Genie and went to Maestro because you could do what you wanted to do with it.
Well, I think I could write a MATLAB script that would read that, but I don't know if it's worth it or not.
The issue is this proprietary way of storing the data that they use.
Yeah.
Other people see it. Hi, what's everybody wearing these things?
This is Dr. Gould. This is Miss
Hello.
Morrison.
Oh, you just came from cheerleading camp.
Oh no, I have a pep rally and stuff tonight.
Okay.
Okay, so they're high school students and they wanted to learn about nuclear weapons, so they called me.
What are you pepping up around here? Give us a bit of a...
I'm going to go show them the detector in a minute.
Yeah.
See what a
I
spectrum.
really wanted to put them looking at 3 lead blocks, 3 lead bricks to get from my car to here. But that would be unfair. They weigh a ton. And I'm driving around at 5 o'clock.
Okay, so you're going to be around here at 5. I'll give you a hand with them.
Yeah, maybe you could. I'll try to zoom out there when the
Okay.
gate goes up. Get it at 5.
All right, okay.
Thanks.
Dr. Gould does nuclear physics as well. Okay, so the question, I've forgotten the question.
the scientists leaving.
Okay, so there were already a bunch of very famous, very excellent scientists in the U.S. Fermi was a refugee from Italy. Italy had the Mussolini at that time. So they had been in the U.S. for some time, and they were, of course, very sensitive to what was going on in Germany, both socially and politically and in terms of science. So they were the ones that pushed. Einstein wrote a very famous letter to President Roosevelt that was sort of the kickoff that convinced him that this effort was necessary.
Do you know how sterile the lab has to be to make the nuclear? Does it have to be extremely clean, or?
I do not know. It doesn't have to be sterile. I mean, not biologically sterile. These laboratories are working with high precision equipment. It turns out that when you make the parts of a bomb, the shape of it is very important. There are two ways of making a bomb explode. The idea is that you have to have a certain mass of the fissile material, be it uranium or plutonium, in order. This is for a fission bomb. You have to have a certain amount of it to make it explode, and you need to assemble this in a very short time. If it suppose you needed a kilogram of uranium. I don't know what the critical mass is, but suppose you need a kilogram of uranium. Well, one way you could envision making a bomb is you just take 5 or 6 smaller blocks of uranium and you put them together. Well, that will reach criticality, but it won't explode. It'll just produce an enormous amount of heat and radiation and a lot of waste. In fact, that is the terrorist way of making a nuclear bomb. It wouldn't produce a big explosion, but it would produce so much radiation it would contaminate New York City for 500 years or something like that. Okay, that's a terrorist bomb. But if you want to make a bomb that'll produce a bang, you have to, for instance, take two parts, two halves of the material, and bring them together in a very, very short time. And the two bombs that were dropped on Japan, one of which literally had two parts, and they were just pushed together by a plunger very quickly. And another one had one part that was not quite enough to produce a reaction, but it was surrounded by explosives, and it compressed. They fired off the explosives, and it compressed it so much that it became critical. So they're firing, they're going to criticality in thousandths of a second.
So like, what are some like effects of it, of like the bomb? Like I know in Hiroshima and Nagasaki, like the radiation and stuff, but like does it have like everlasting effects on like the soil and stuff like that?
There's very long-term effects on the soil. I mean, people live in Nagasaki now, and in Hiroshima, but well, there was the effect of the explosion. There was the effect of the radiation. People literally were burned to death by the light from it. Long-term radiation sickness. There's short-term and long-term radiation sickness. Increase in cancer rate. Increase of mortality among newborns. The whole schmoo is awful.
So birth defects were like high.
Birth defects, and they contaminated a large part of the town. Destroyed. I mean, it was awful. And I grew up at a time when I grew up in the 60s when the U.S. and Russia or the Soviet Union were really at odds, far worse than they are now, and there was a lot of discussion about what would happen with nuclear war. We had drills when I was in school, and
I remember in history we learned about the Duck and Cover song.
I don't remember that one, but we learned about that. There was a period, I grew up in South Louisiana, there was a period in 1962, in October 62, when it was found that Russia had shipped nuclear weapons to Cuba. And Baton Rouge, as much of the southeast, was in range of rocket range of Cuba. So there were people who had built bomb shelters, and they were behind their houses. And for a few days, it was actually everybody in the United States thought there was a possibility of a nuclear war. Fortunately, the U.S. made a strong response, put an embargo and ships around Cuba, and the Russians decided not to pursue it. So I don't think the weapons ever actually made it to Cuba.
So I had read something about there being a nuclear bomb in the sand down in Georgia. Is that true? That never exploded?
Yes. There was one actually in Kinston that there was an accident of a plane that I think it was a B-52 that crashed near Kinston, and the bomb, fortunately, was not armed. There's all various fail-safes on those bombs, but the materials were recovered. I think there may be one that was not recovered, but I'm not sure of the details of that. There's a lot of folk stories about that.
Could those bombs be, like, if they were found, could they still work?
No, not likely.
So you're saying that there's like uranium and you have your plutonium. Sorry about that. What are like the main differences of those? Like, are they just because like I heard that I think it was either uranium or plutonium. Their things aren't like the amount of like pure uranium isn't like enough, so they had to add something to it to make it more like so that it could explode. Or
For uranium, there are two isotopes of uranium. Do you know what an isotope is? Okay,
Yeah.
different number of neutrons, and you need if you mine uranium in a mine, you get mostly uranium-238 and a small amount of uranium-235. They're just their natural abundances. You need enriched uranium. You've probably heard that term on the news. And the issue right now is North Korea, or the issue with Iran is that they want to maintain the capability of producing enriched uranium. And what that means is it means separating out uranium-235. So you need that to make a bomb. Okay. So all right. So this is how you make a fission bomb. There are two ways. You have your enriched uranium-235, and you surround it with explosives and some metals. There's more uranium there that's used to kind of control the flow of the neutrons, and you just explode this, and it compresses that piece in the middle, and that leads to that when they compress it so much, it goes above critical mass and it explodes. The other way is that you can have a sample of U-235, in this case in a sphere, with a hole in it, and then you have another sample of U-235 that would fit in that hole, and then you have some explosive here. So you literally push that plunger of 235 in to fill up that hole, and then it becomes a critical mass. Okay.
Okay. Okay. Thank you.
I had a question.
So, do we still have capabilities of making nuclear bombs if we need to? Like,
I think we do. I think it's. I'm not really sure. The impetus now is to reduce arsenals of bombs. The United States and the USSR have agreements to decrease the number of weapons over the next few years. I know that the U.S. is decommissioning a lot of its weapons. Most of them are hydrogen bombs, which operate with a little bit different process than the atomic bombs that we discussed. So the stock, they call it stockpile stewardship. There are two issues where you want to be able to reduce the number of bombs, but you also want to make sure that you have enough bombs that are working so that if you needed them, they would be there. And so you would think, well, we're reducing the number of bombs. We're trying to reduce the nuclear arsenal. Why do you need all these scientists and engineers and installations to be concerned with them? Well, you have to maintain the bombs. You don't make a bomb and set it aside on the shelf. It actually has to undergo maintenance. And some of these bombs were made 20, 30 years ago, and how do you know whether that they will blow off after 20 or 30 years? I have some colleagues at Los Alamos who actually spend time trying to figure out how to test bombs without actually blowing them up. You know, how to make sure. It's like you got your car out in the driveway, you haven't driven it in 3 years. How can you test whether it's going to run without actually getting in the car and turning the key on? And there are ways to do that. So.
Yeah. Do you have any ideas for us to be able to look up, or that you could probably answer for us, to help our project?
See.
We can.
Okay.
Great.
I'm going to work through that document and send you some comments.
Okay, Vince is going to be here Wednesday, so that's sort of our hard deadline.
For the CCD?
Yeah. Vince will be here Wednesday afternoon.
Okay.
So it'd be nice to have it in our spreadsheet. By
Okay, that's very much on my list for this weekend. Sorry, I'm not finished with it yet.
Oh, that's fine.
Okay. Questions?
Yeah, it was really hard trying to find this stuff. Like, I had to dig up and like, I had to result back to some World War II questions about like how to, like the Manhattan Project and.
Yeah, some of the stuff is kind of hidden on the internet, so.
I don't think it is.
Yeah, I was looking.
It's just you have to look it up, like a certain thing for it to pull up, and then you're like, oh, there it is.
Well, what? Let's see. What would be an interesting question? So, is this for a science class or for a history
it's
class?
for chemistry.
Chemistry. Okay. Well, some of the chemistry problems are how you mine uranium.
Yeah. Is that
And you have to separate it out. There's a lot of some of the issues with making bombs was how you find and produce uranium before you enrich it to make bombs. You're specific. Well, let me ask you a couple other questions. Are you specifically interested in nuclear warfare or nuclear power or in the chemistry?
just on the chemistry and kind of, chemistry part of it. There's like chemistry and warfare part of it is what like he said to look at more or less. So,
Okay, the warfare, because Dr. Gould coming in reminded me that there's one very interesting topic that few people know about is that they're actually natural nuclear reactors.
Really?
Yeah, there's a set of uranium deposits in Africa that function as reactors. They actually heat up. It's just pockets of minerals in the ground that contain enough uranium that whenever it rains, the rain acts as a moderator to keep the neutrons inside. They actually have turned into nuclear reactors, natural nuclear reactors.
Has there been any like other places where you could find that?
I think those are the only ones. The Oklo nuclear reactors, OKLO. Let's see. Well, I think the big issue in nuclear weapons right now is Iran.
Are they the main like people that we're looking at? Because don't they have do they have the capabilities of that?
They have the capabilities. The U.S. and its allies are trying to keep them from making use of them, and it has to do with their ability to produce enriched uranium. Okay, like I said, you to make a bomb, you have to make a sample of uranium that's mostly the 235 isotope rather than the 238 isotope. To make a reactor, you only need something like 5% U-235. For certain reactors, you use 20%. For instance, nuclear submarines use reactors that run 20% U-235. To make a bomb, you need 95%. And the issue now is the U.S. is quite willing to let Iran produce 5% enriched uranium. Iran wants to make 20% for its reactors. But once you get to 20%, it's very easy to switch over to make 95%. And so the fear is that if you allowed them to make 20%, they would soon be producing bombs, or you wouldn't be able to prevent them producing bombs.
We have such a strict limit on them because like we feel like they're just gonna do that instead of like listening to us.
Yes.
Okay.
North Korea is a different case because they have had the capability of producing bombs. I think they've fired off a couple of them in testing, and they, North Korean politics and government is so weird anyway.
I think that's it. Is that good?
Yeah.
Okay.
All right.
Thank you so much.
Thank you.
Let me show you a nuclear experiment.